Welcome back to Dave Does Math at Home. We are still doing section 1.6, other equations. This is part 2. In part 1, we talked about polynomials. Those are the same as quadratics. You set one side equal to 0 and you factor the rest. We also talked about radical equations. You have to isolate the radical and then square both sides to eliminate the radical. And then that leaves you with usually a quadratic, sometimes a linear function, depends. The last flavor of function we need to talk about, and the focus of this video, is going to be power. I keep saying functions. We're not dealing with functions, I'm sorry. We're dealing with equations. We need to talk about power equations. Power equations sort of look like x raised to some unfortunate looking exponent and having that be equal to some number. These are always kind of tricky because the powers involved are usually fractions, and we have to be very careful about how we deal with fractions. And my technique for solving all of these sorts of problems is, once you have the power piece isolated, I think you should split it up into two pieces. We talked about in section P2, I think. P2 is exponents. In P2, we talked about this property of exponents, where if you have some exponents raised to other exponents, you can sort of transform that into a to the b times c. Yeah? This is the thing we did. What a lot of people don't realize immediately is that this works both ways. You can go back and forth. And for something like this, I think it's much easier to express the 3 and the 3 halves as x to the 1/2 cubed. So all of these fractional powers, I think it's best to split them into pieces where you have a whole, like extract the numerator so that that's just a whole number on the outside of everything. And then leave the denominator as a unit fraction, just 1 over the denominator, leave that on the inside of the parentheses. We can see that if we were to combine these, you would multiply the 3 and the 1/2 and you would get 3 halves. So that hasn't changed. And the thing still equals 27. When you split this power into two pieces like this, working with each piece individually becomes much easier. For example, right now, if we want to solve this for x, what we need to do is get a different colored marker and take a cube root of each side. The cube root will cancel the cubed, and the cube root of 27 is 3. So you're just left with x to the 1/2 equals 3. And then you cancel the other half of the power. If you want to cancel 1/2, you would square it. X to the 1/2 squared is just, these guys cancel, and that leaves you with x. 3 squared is 9. And that's pretty much all there is to it. You take your power, you break it into two pieces, numerator on the outside, unit fraction on the inside, and you deal with those two pieces separately. I'm going to do another example so we can look at what that looks like. And I'm going to write that down. For power, split into numerator on the outside and unit fraction denominator on the inside. So you can deal with those pieces separately. So the other thing I want to do is x plus 3 to the 2/5 equals 4. there's one other weird trick that we have to be very careful of when doing these things, and I will explain that in a moment. First, I want to talk about splitting this up. So I'm going to take the x plus 3, that's not going to change. I'm going to put the unit fraction denominator on the inside, that's the 1/5, and I'm going to put the numerator on the outside, that's a 2, and we'll say that equals 4. The next step would be taking a square root of both sides. And this is what we need to talk about. Hopefully everyone remembers we dealt a lot with take the square root of both sides in section 1.5. We called that the square root technique for solving quadratic equations. And we said that it had some complications. There are some things that make doing that very awkward. And it's basically that when you take the square root of something, you have to acknowledge that you might have a positive or a negative version of that thing. So this piece has been squared, and there are two numbers that you can square to get 4. So this stuff on the inside, this x plus 3 to the 1/5, maybe it was 2. Let me write this somewhere else. I'm running out of room. X plus 3 to the 1/5. Maybe this bit on the inside that got squared was 2, and that's why squaring it gave us 4. Or maybe that bit on the inside was -2, and squaring it gave us 4. We didn't have to worry about this in the last problem because in the last problem we took a cube root. And cube roots preserve the sign of the thing. Like the cube root of 8 is 2, the cube root of -8 is -2. This isn't a problem with cube roots or with any odd root. Cube roots, fifth roots, seventh roots, those are all fine. This plus and minus situation is only an issue with even roots. If you're taking a square root of something or a fourth root, you have to acknowledge that the thing you just took the square root of might have been positive or it might have been negative. So we got our two possibilities here. We proceed like normal from here. We need to deal with this 1/5 business, and we deal with the 1/5 business by raising everything to the 5th power. Both equations. So the 1/5 and the 5th will cancel, and that's just an x plus 3 over here. 2 to the 5th is 32. Same thing happens here. We get an x plus 3, except this time it might be -32. And then we just subtract the 3. So x is maybe 29, or x is -35. This power equation has two solutions. Anything that has an even numerator will have two solutions. Because even numerators mean you're taking a square root or a fourth root, and you'll deal with plus and minuses, and that'll give you two answers. That is the end of the lesson on other equations. Let me make a quick written note. Denominators on the inside, and as a special note, be careful about plus and minus with even roots. So that's polynomial equations, radical equations, and power equations. Those are the three flavors of equations that we're dealing with in section 1.6. Try the homework, let me know what you think, and I will See you in the next video. Next up is 1.3. We're kind of jumping around a little bit. That's okay.